of the series. I used to actually give part of this as the first part of a four-part series. But because I changed it completely this year, I decided nevertheless to leave that first part and present it today. Because probably it'll shock you a little bit, and you'll learn something from it. And I will rediscover it with you because I haven't looked at the slides for a long time. So what we talked about last time, this is not working, we have to turn it on. We talked about artificial intelligence being part of computing science. And within artificial intelligence you have machine learning, which consists of giving means to the computer to learn something. And within machine learning you have a special case of supervised learning we call deep learning. Okay, they're non-equivalent, is one inside the other. And I told you that AI is not new. You may have heard about it recently, but it's been around since the 50s. The term was coined in 1956, so it's been a long, long time. But there is a significant resurgence of AI, and the reason I told you is because of these three major factors. We have today a lot of data, more data than we ever collected before. We also have very powerful computers, and I showed you how fast this has evolved. Today's computers can do amazing things that we were not able to do a few years ago. And the third factor is the fact that we have now sophisticated algorithms that, well, some of them existed in theory, but we never actually used them to the extent we wanted. Until now we have these computers, we can run these algorithms exploiting this data, and we can do amazing things. I also introduced what machine learning is, at least supervised learning. And supervised learning, I said, you have data that has been labeled before by experts in the application domain. And then you run an algorithm through that, and that algorithm will learn. What does it learn? Well, it learns to distinguish between the different labels, the groups that have different labels, and it creates a model that represents that, what differentiates the different classes. That model can be different things. It can be mathematical formally, it can be a neural network, it can be a hyperplane crossing the search space, it can be many different things. I will use then that model to classify new objects that have never been classified before. And it's like a prediction. I'm predicting what is the appropriate class label for this one, for this one, for this one, based on what I learned from this experience, using some kind of analogy with what I learned before. Okay? That's what supervised learning is. And after I talked about that, I also mentioned some examples in the case of precision health. Okay? And the use of machine learning in precision health is key. I gave you many, many, many examples. And I also mentioned that in precision health, it's not just about genes and mutations in the genes, the SNPs. It goes way beyond that. We can use any data that you have about patients or things in the medical domain, and we can also do precision medicine with that. So AI is a transformative technology, not only for medicine, in everything that you do every day. However, many people are warning us, watch out, that's an enemy. AI will actually destroy the human kind. It's a danger. And it's because of this view of them against us, the machines against the humans. They're potential enemies. And it's not anybody who says that. You have very famous people One example is Stephen Hawking, who said that the development of full artificial intelligence could spell the end of the human race. And I'm glad he was precise by saying full artificial intelligence. He didn't say artificial intelligence. Why is that? And he's not the only one. You have people like Elon Musk and Bill Gates who also say similar things, that AI can be very dangerous to us. The truth is that none of these guys are specialists in AI, even though Bill Gates is in computer science. He's the founder of Microsoft. But people listen to them. What Hawking also said afterwards, he realized that, well, maybe people didn't understand him very well, and they took his word and amplified it significantly. He actually said that, yeah, there are many other dangers. If we survive those, maybe this will become an issue. And actually the biggest threat to humankind today is capitalism, and he explained why. Because of the people who have the means will create maybe these robots. The robots will automate everything, and then the others will not have jobs, and then the gap between the rich and the poor will increase, and it's not sustainable. So, yeah, he mentioned other dangers, and then we have to think about going to space and all that. It goes on and on. And he said in the next 100 years, we have to be able to colonize other planets, otherwise we're doomed if we stay. And I invite you to go and listen to his interview on the BBC. So, despite that, well, we achieved amazing things with AI. I'm going to enumerate some of them here. In 1997, you and I at the university. I don't know where you were in 1997. But then, IBM Deep Blue program was actually a computer, the whole hardware, and the program dedicated to chess beat the world champion Garry Kasparov at that time, and it was amazing. Everybody said, wow, we're doomed already. I mean, computers can beat the best at chess. I mean, they can do everything. That was in 97. That's 20 years ago. Before that, in 94, in checkers, here from the U of A, Jonathan Schaefer, our former dean, still dean for
a
few days, he was leading the project Chinook to build a checkers game, and he participated, well, Chinook participated at a world championship, not like Deep Blue where they have this match with Garry Kasparov. We invite you to play against us and we'll give you $1 million or whatever, how many $1 million at that time. Chinook actually participated at the World Championship and earned the right to challenge actually the best in the world, and they beat the best in the world. Actually, the last match there was a draw for health reasons. And in 2007, checkers was solved. Solved, it means that you can't beat a computer anymore. There's no way on earth you can beat the computer because it knows all the possible solutions. In 2011, you probably heard of Watson beating the humans at Jeopardy. Do you know the game Watson on TV? So you ask a question, there are questions, and you have to answer these questions. There are many facts, and it's amazing. These people know a lot of stuff, and they make a lot of money, and some of these humans are unbeatable. And then suddenly you have this computer, Watson, that beats the best in the world. That was incredible as well. It's a question answering system. Driving self-driving cars, driving across the United States. That was done in '95, already 3,000 miles from Pittsburgh to San Diego. Not really the whole coast to coast, but it's a long, long way. And in 2004, 2007, DARPA had actually competitions where many people participated with cars driving in very sophisticated paths. And now everybody's talking about actually having a self-driving car very soon in the roads of the city. Well, the problem now is not actually the self-driving car per se, is the other cars driving at the same time as the self-driving car. And people throwing themselves in front of the self-driving car just for insurance purposes. I don't know if you read the news, it happens all the time. Here in Edmonton at U of A, we also solved the heads-up limit Texas Hold'em poker game. And with the no-limit version, we beat professional players. So, incredible achievements. So I'll tell you about another achievement, and I'm proud to say that U of A is also involved. By starting from the beginning of the story, David Silver, an Australian student, came to do his PhD here at U of A in computer science. And he was supervised by Rich Sutton, who's specialist in reinforcement learning, and Martin Miller, who's also an AI, but he works in heuristic search. Heuristic search is when you have a large search space, you can't search it all. There are some heuristics that we use to cut the search space and find the solution. He was also working on planning, and one of his research goals is to improve the AI on the Go game. It's a board game played in China that is called Go. In China, they don't know actually the name Go. Apparently, it means dog. They know Wei Qi as the name. The name Go came from Japan, because the way they call Wei Qi, they call it something Go, and the Americans call it Go. Anyways, David Silver worked on the Go game, and at that time, when he started, we didn't have a program that could beat humans. We had programs that beat the best at chess, the best at checkers, but not at Go. Actually, the best programs could be beaten by kids, 9-year-old kids. It's so tough to beat humans. But people were working on improving this system. So David Silver worked with these two guys from U of A, Professor Miller and Sutton, to use reinforcement learning to teach a program to learn playing Go. And by the time he finished, he had actually a Go program that can play at the master level. That was amazing. When he finished, he was hired by a small startup called DeepMind in London. And DeepMind didn't have products. Their goal is to work in AI and come up with some general artificial intelligence. And he was given the task to work on something that, well, he likes working on, like his PhD, and achieve some interesting results. So he was the leader of the project called AlphaGo. In AlphaGo, the goal was to do a Go player that can beat humans. They did amazing results. They achieved amazing results, and they invited the European champion at just an exhibited kind of game, and they beat that European champion. The Asians said, well, that's nothing. That's the European champion. He's ranked 155 in the world. We have better players. So, before we reach that, so that wasn't a big deal. A year after Google acquired DeepMind, in the end of 2013, in 2014, Larry Page was interviewed at the TED talk show in Vancouver, and he said one of the reasons Google acquired DeepMind is because he was fascinated by something that they were working on. You know the Atari game from the 80s? They have many arcade kind of games like these. And DeepMind created a program that can learn to play these games, but not one program for each one of these. It's one program that can generalize and play all these games, and in many games it did better than humans. And that was fascinating. Why? Because many of these AI programs are very specialized. Deep Blue is very good at playing chess, but it can't drive a car. The program that recognizes these signs cannot be used to play checkers. Okay? So we have very specialized programs. Here you have a program that can play many games at the same time. So it's not specialized. So that was fascinating. Very few people knew that this project is also one of our students from the University of Alberta that was hired by DeepMind that was developing it. Okay? And it's still working here. This is the arcade learning environment that we have here at U of A. Anyways, Google DeepMind, after beating the European champion, they didn't impress the Asians. So they challenged Lee Sedol, who was 8-time world champion, Korean guy, and they beat him. That was a shock. Oh my gosh. Yesterday we couldn't beat a 9-year-old kid, and now the 8-time world champion is beaten like that. The Chinese said, well, it's okay, we have our best world champion of the year. And Lee said, oh yeah, he was the world champion, but he's not. So they challenged KG, and KG was beaten as well. That was a shock in China, and that led the Chinese government to invest billions of dollars in AI because they realize it's serious. And that's why also Putin mentioned those who will master AI will actually lead the world. Remember what I mentioned last time. It didn't stop there. Because when they used reinforcement learning to teach the program to learn how to play Go, they looked at previous games of champions and they learned from what other people have played. And they said, okay, let's start from scratch. I'm not going to give AlphaGo the previous games. I'm going to ask it to play against itself and learn by itself. Here are the rules of the game, and play against yourself and learn. They call it AlphaGo 0. It means to start from 0. And AlphaGo 0, after a few hours of learning by itself, it beat AlphaGo, that beat the best in the world. Completely. I mean, this was in October 2017, so less than a year ago. About a year ago. And again, it didn't stop there. They said, since we just gave it the rules of the game and it plays against itself, and it beat the previous version of AlphaGo, and remember, DeepMind is trying to find something that is general, not just specialized in one thing. They said, okay, let's give it other rules. We'll give it the rules of chess. And will it learn chess? This is to prove that it's not just Go. I can also learn other things. And indeed, this is what they did in December. So a few months after this achievement, I mean, this is going very fast. On December 6, 2017, they gave AlphaGo 0 the rules of chess. And they played against, they can't play against humans because already we beat the humans. It's been 20 years that we beat the humans. They actually played against the champion program we have today in chess, and it beats it 0 to 100. After a few hours of learning, playing against itself, using reinforcement learning. So, yeah, we're doomed. we're doomed, computers will replace us and will enslave us. That's not true. This is what people want you to believe, but this is not my belief. So yes, we achieved incredible feat with Jeopardy, AlphaGo 0, and so forth. I'm going to ask you the question, who thinks that a computer robot could pass a university entrance exam? So there are many universities. To enter the university, to register, you have to pass an entrance exam. Do you think a computer can do that by 2020? Was it too close? 2020 is in 2 years. Who says yes? Who says no? Okay, let's make it more difficult. Who thinks a computer robot could pass a bar exam to become a lawyer by 2030? 12 years from now. What if I tell you that U of A team has already built a program that can pass the Tokyo entrance exam, Tokyo University entrance exam, and can pass a Japanese bar exam? It's already done. That doesn't mean that that program can be a lawyer, can pass the exam. And that doesn't mean that that program can actually now attend classes at the Tokyo University. But it does way better than the average students who enter that exam, and better than the average students that are trying this bar exam. That tells you something. I'm going to try to open the box. This is the black box called AI. I'm going to open it to show you sometimes when you see inside, you realize it's not as fascinating as it may seem. So the Jeopardy program, it's a game on TV where you have competitors and you ask them questions and they have to be fast and press the button and then give them the chance to answer that question, and they answer the question by creating a question. Say, something, this, something. So you have facts. So for example, the question, Mozart's Last Symphony shares its name with this planet. It's not a question, it's just a statement, but you have to answer with a question. And all these questions are factoids. So you have to know these facts, and you have to retrieve them very quickly and answer before the others. So how can Jeopardy, the program, Watson, answer the question, Mozart's Last Symphony shares its name with this planet? Do you know the answer? Well, Jeopardy knows it. And I'll tell you how it knows it. So you see here, I need to find this something. And what is the fact that I'm looking for is this planet. So the question I have to answer, the question that I have to generate to answer this, is about a planet. Okay? That's why I'm highlighting it. And this is how it does it in a nutshell, at a very high level. I will take the keywords here. The keywords are Mozart. I have symphony. And it's not just symphony, it's the last symphony. Okay? Mozart's last symphony. So last symphony, Mozart. And I'll query that on a search engine. Okay? When I query it on a search engine, I get a result like this with your favorite search engine, Google or whatever. Okay? And then, in this page, I'm going to read it. I'm the computer. Do you think I'm going to understand it? No, not like you humans. I'm going to look for keywords, the keywords that I was looking for. So I was looking for Mozart's Last and Symphony. So I'm going to look at where is symphony and Mozart. So for example, I have one of these pages is symphony number 41, Mozart in Wikipedia. I'm going to open that page. And in that page, I'm looking for Mozart, symphony, and something that is like a planet. So I'll read the page. No, I will not read the page. I actually don't understand. I will just look for these words: symphony, Mozart, Mozart, symphony, 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 Mozart, last symphony. Okay, and then I will find something that co-occur with these words, but also is related to planets. So I search for planets. Remember, planet is underlined. And here are the planets. So one of these words, does it co-occur with these? And I will find that indeed Jupiter, symphony, Jupiter happens here. What is Jupiter? That's the answer. And because computers can do that very fast, before even I think about it, boom, it's done. Yes?
How can it determine what are the keywords to pull up?
Oh, well, that's trivial. There's a natural language processing that you can do, and you find the name entities. You extract these name entities, and the name entities are the keywords in this case. So Mozart, symphony, planet, these are names. And that's how they get the answer. So now that you know how it's done, when you watch it answering faster than humans, it's not a big deal. It doesn't understand what a symphony is. It doesn't know who Mozart is. It doesn't even know what Jupiter is. But it can get you that answer. And it's impressive. But it mimics what we do. It doesn't do it the way we do it, but the result is phenomenal. Okay. What I was going to say after. What if I ask, so that's a factoid kind of question. What if I ask a question true, false? So many of the entrance exam, like I mentioned, university entrance exam, you have true, false, or multiple choice questions. So what about true, false questions? True, false. Charlemagne repelled the Magyars. How can the computer say yes or no to that question? Well, it transforms this question into a factoid question. So Charlemagne repelled who? Okay. So I'll do a search with Charlemagne and repel. And I'll find many sources, and I will find different answers. The Avars, the Magyars, the Franks, and with different probabilities. And the highest one, the Avars. Oh, that's not the Magyars. So I'll say false. Okay? And I can do the same thing for what we call agglomerative questions. So if I say, who are the 3 last presidents of the United States? It's not just who's the 40th or the 43rd president, one fact. I can have many facts. And I can divide it into many questions, get them all together, and put them together and answer. So all these are feasible today. Okay. Yeah, I mentioned this about people saying that the AI is nevertheless dangerous because it's evolving very fast, and it's actually faster than we expected, and it surprised many people, even the specialists themselves, to say, oh my gosh, I didn't expect it to be this fast. So that's why they think if we continue that same trend, yeah, it can become smarter than us, and what does that mean? That becomes dangerous if we don't pay attention to it now. So the people, it's so serious that people are actually creating these groups and centers and think tanks and whatever to think about it. For example, the Future of Life Institute was created in 2014 to consider all the threats to humankind, nuclear war, biological war, whatever, all these problems, and AI is one of the risks that they are considering. So they're particularly thinking about the risk of artificial intelligence. The problem is that people are always looking at them against us. And, first, there's many specialists who don't believe that the threat is this close. I think AI will be as smart, if not smarter than humans in the future, sometime in the future, but I don't think it's in the very near future. However, things happen very suddenly, so who knows? But I want you to think about this thing here, just to compare how we think and how computers think. If you see a picture like this, and then you give it to a computer, we talked about last time some of the achievements of AI. Computers can identify objects in pictures, and we are doing actually better than humans today. If I show this picture to a computer, what do you think the answer would be? Pencil. Right? So pencil. Can be even more sophisticated. Say pencil, hand, and writing. Okay, give you action. It can be even more sophisticated and looking inside here and can even identify the person. Tell you, hey, I know the fingerprints. But if you show to a human being, they may say other things. What do you see? What do you see in that picture? Nobody wants to volunteer something. So a computer says, I recognize a pencil, yeah? Humans say, I see a weapon in the hands of a fearsome writer. You may even think, you're a student, you may think somebody writing an exam or whatever, you can come up with a story around it. We don't think the same way, and there are many reasons why. We can bring it up in the discussion if we have the time for a discussion. So is it paranoia or is it justified, this fear of computers? These computers can allow us to do things that we were not able to do on our own, recognizing things on pictures and transcribing things from voice so for voice recognition and things like that. But hey, people have been warning us from day one. Ray Solomonoff is one of the founders of AI, and in the early days, this is in the 60s, he said already, very intelligent machines in the near future can cause dangers, very serious. And the problem can become very difficult. It's what he says, it's important to have people think and devote time, consider this before it happens. And I think that's logical to do. We should not ignore it and say, well, it will not happen. We should consider it and think about it. What if it happened? What should we do? Okay, and so this leads to the discussion about technological singularity. I don't know if you, this semester, they have done it already?
Yeah, in a superficial way.
A superficial way. So the technological singularity, it's the hypothetical future where computers will be more intelligent than humans, and in that case, innovation will be driven by computers, not by humans anymore, and because they can innovate themselves iteratively in a recursive way, it'll go very fast. And after that, we cannot predict what can happen. We don't know what can happen and how fast it can go. So that's what we call singularity, and some people say, well, that's science fiction, it's not real. Well, in theory, it can happen. When, that's another story, and people have been speculating when it will happen. Personally, I don't think I will see it, but it'll happen. I know it'll happen, but I will not see it. So why it can happen? Well, they can very easily think about it. Imagine this is the path going forward. This is artificial intelligence today. This is the animal intelligence. This is human intelligence. So humans are better than animals, and many animals are way better than computers. Okay. The progress of AI is the strain. Why do you think the strain will, well, it's improving from current AI. Why will it stop here and do better than animals and stop? It will continue. And if it continues, why would it stop here? It can continue beyond. Okay. And if it continues beyond, what will happen? However, think about something. We humans, and also animals, we have emotions. Computers are not emotionally intelligent yet. They don't perceive the intelligence of the others, and they do not express intelligence. we have also instincts, and we are sometimes guided by these instincts. We don't know why we're doing that, but we do it. We are inconsistent how we do things. Computers are very consistent. We seem to sometimes act without reason. Why? I don't know. I have to go to school, but I don't feel like it today. Have you felt like that? Yeah, of course. And we are also self-aware. All these things are not in computers yet. It doesn't mean we can't have them in computers, but we're not there yet. So here's another reflection about the singularity. If you look at a mouse, that animal that I said is intelligent, is it really intelligent? What is intelligence? So this animal, if it needs to get food on the other side of the river, it'll swim, because it needs to survive. It'll swim, it'll adapt. There's a flood, it'll adapt and find another way where to continue to procreate and eat and all that stuff for the survival of the species. If it finds cheese, it'll eat it. It's not from nature. We build the cheese. We make the cheese and it'll eat it. Needs to build a nest. If it's in the field, it'll build its nest with what it finds. If this animal comes to my garage and needs to build a nest, it'll adapt to what it finds in my garage. Paper and cardboard and plastic and even chewing on my cables of my car engine. They did. If you put a mouse in a maze, it'll learn that maze. It'll solve the maze, and it'll remember the maze, and if you put it back in, it'll find its path without hitting these cul-de-sacs. Heck, you can't even teach this animal to count. 1 + 1 is 2, and 3 - 1 is 2, and so forth. However, if that animal gazes at the stars, does it understand that they're not holes in the sky with lights there, they're planets? Okay. Does it imagine, oh, maybe there's a planet that has other mice? No, you can't imagine that. When it looks at the cheese that it loves and eats, does it think about the protein inside it and the folding of these proteins in 3D? No. When it goes in my engine and chews on the cables, does it know what that engine is for? That's moving the car, and how the combustion is happening in the engine? No. Looks at the rocket ship taking off, has no idea what it is. Okay? I was always wondering when I went out in the dark and I turned on the light, what did my dogs think that happened? That I have the power to bring the light? These mice, even though they can count, I have 3 babies that are moving from this nest to the other nest. I didn't forget one. I know I have 3 or 5 or 6. They know how to count, but they can't count abstractly. They can't do math. Okay. Because they don't have the same brain as us. They don't have that same experience. They don't have, nature didn't give them the same capabilities. So the mouse that animal is intelligent. It's less intelligent than us, but it doesn't imagine the intelligence that we have. Can you imagine that the mouse can figure out the intelligence that we have? It doesn't understand what math is and what planets are. So, if that is sub-intelligent and we are intelligent, and this sub-intelligent cannot understand our intelligence, we understand we can understand their intelligence. How can we understand a super-intelligence, something bigger than us? So if we put ourselves in the position of the mouse, we can understand that intelligence. That intelligence can be a computer, can be something else, I don't know. So we cannot conceivably think that a mouse could comprehend our degree of intelligence. It only thinks that, wow, that's a threat. That's something that can kill me or something. It's bigger than me, dangerous, run away. So we can't comprehend that intelligence. We cannot comprehend the intelligence of something bigger than us. We can imagine that it can exist, but we don't know what capability it can have. Okay. So that singularity is possible, because there is a possibility of having something super intelligent. So the question is, how do we get there? We are the most intelligent being on this planet. Can something else exist or become? So there are four paths. For me, there are four paths to what we call singularity. One is, well, we humans ourselves become more intelligent. How? Well, with evolution. Well, if you take, like Aristotle from the 4th century, if that same being, the baby, was brought to our 21st century here, they will be as we are. And that person will be as intelligent as us, except that they didn't have the knowledge that we have today, that we have accumulated for all these centuries. So the intelligence didn't change. That machine is the same, because evolution is very slow. So I don't think we can do that, except if we help evolution. Yes, it's unethical, but suppose we do it. Okay, by selection. We could, but that will take a long, long, long time. But it's a path. Another path is this artificial intelligence, that someday it'll exceed human beings. So I mentioned, for example, the machines are getting faster and faster, and now your phone is as fast, as powerful as the fastest computer a few years ago. Yeah, but that's hardware. Hardware is not software. Software is what is running on that hardware, and that is taking a long time still. Yeah, we still have to go a long way, unless the computers themselves start writing programs. You know when I'll be scared with this technology here? If I can tell a computer, here's a research paper from this journal or this conference, read it, analyze it, and improve upon it. That's what we do with grad students. A grad student will read the research paper and criticize and improve upon that. Computers can't do that yet. But if they can write their own programs, maybe they will improve the software fast enough to catch up on this hardware. Okay? So I'm not very optimistic to have a fast path through here, even though many people are saying this is dangerous. Where I think it'll happen is the third path here. It's the mixture between humans and machines. And this is happening already today. So this is what some people are calling cybernetic singularity. So we will enhance the human body such that it goes beyond the innate intelligence that we have now, with extensions and stuff like that. This is a movement called the transhumanism movement. There's I was intending to show you a video of a guy who adds a lot of these sensors on his body. He was interviewed recently on CBC. It's phenomenal, because there's no regulation. People do a lot of stuff. They call it body hacking. They hack their own body. They add things. I'll show you some pictures. There's a fourth path. And the fourth path is something that a few people are considering, but it's a plausible case. It's when you put many small things together. Each one is intelligent, but with some small intelligence. Together, something can emerge that is more than the sum of each. Build large computer networks in which beyond intelligence emerges. What kind of large network? For example, the Internet of Things. You have an intelligent thermostat, you have an intelligent toaster, an intelligent TV, an intelligent watch, an intelligent fridge, and sensors on the highway, on the car, and all these are connected with the Internet of Things. Plus the big computers are also connected on this Internet of Things. Something can emerge out of that. And the analogy is, you can't see it here, and I normally have a video here. The analogy of the ants. If you take one ant is not that smart. It's not intelligent. And it follows some rules hard-coded in their DNA, with some instincts. You have roles. You're a soldier. You're this. You're that. Do that. But they're collective, put together. They build amazing things. So this video shows, for example, scientists pouring the liquid metal, or actually concrete in some cases, in the ant's nest. Okay, and let it dry, and then they dig it, and you see all the rooms that they have, the connections, and this architecture is phenomenal, what they have inside there. And you can't imagine that one ant designed that architecture. But from the collective, something emerged that is amazingly intelligent and powerful. And the same thing can happen with the Internet of Things. So these are 4 paths that I consider. I want to talk a little bit more about the third one to show you how plausible this is. When people are mixed, when a human body is mixed with machines, we call it cyborg. Okay, a cyborg is a cybernetic organism, biological and artificial being, mixed. Do you know this picture? This is Captain Picard from Star Trek, Enterprise, when he was abducted by the Borgs. And the Borgs live in this collective, and they assimilate all the civilization they colonize, and they are all connected like ants. This is when he was assimilated. I'm using him as an example. Well, people often think about the human body to which you add these mechanical, artificial things. And we already have cyborgs today, with an artificial limb, artificial knee, artificial eye, all sorts of things. But actually there's another path. So here we have these artificial limbs. And I told you we have an example, and actually on Thursday, Patrick Pilarski will talk about these here in class. But there's another path. You can actually take robots to which you add cells, biological cells, and that's a cyborg too, and it's possible. I also have a video that shows you these robot rats. It's a robot that is managed by a rat cell. So there's a rat cell, they put it on the computer, and the computer with Wi-Fi connects this to this robot, and the behavior of the robot is dictated by this rat cell from the rat brain. And it finds its path in the maze. The interesting thing is that these rat brain cells don't last very long, they die, so they replace them. And when they replace them, you have a different behavior of the rat. So they have the robot is like a cookie cutter, they can build many of them, they look the same, but they have different behaviors because they're dictated by different rat cells. And that's a cyborg too. This is a mixture of biological cells and artificial things. Okay. So here very soon you'll start thinking, oh my gosh, this is like the $6 million man and the bionic woman. I don't know if you remember these TV series from the 70s and 80s. Okay. So people were thinking about them. This was science fiction. This is becoming more and more real. And many movies talk about these data from Star Trek, many of these robots. Okay. So you think it's only science fiction? I'll show you some examples to show you how this future is already here. This is the case of people who lose their vision. They don't see anymore. They become blind because of degeneration of the retina. And for these people, there's technology now, it's being tested, but it's working phenomenally already. It's a chip that is put on the retina and connected to the optical nerve. And like the cochlear implant, you know about the cochlear implant? Cochlear implant has been around for 100 years already. It's something that excites the bone here. Okay? It takes the sound and transforms it into these signals that it sends to the bones, and the bones inside the inner ear are moving, and it creates the sound, and you hear sound that the microphone is capturing and sending to you. You don't hear the real sound, you hear the sound that's generated by this implant here. So we do the same thing here for the eye. You have a chip that is connected to the retina, and the chip receives a signal from two cameras attached to your glasses that you're wearing, the blind person is wearing. And then the signal received by the chip is transformed to a signal that is sent to the optical nerve, and you see images in your brain. So the current technology started with 4x4 pixels, and now it's improving 16 by 16, 32 by 30, and suddenly this person was blind, and now they see shapes, pixelized shapes, and they recognize the image. It's not in color, because it doesn't excite the same, the cone neurons that you have on retina and things like that. But anyways, these are amazing shapes. People who are blind now can see things. And what does this picture remind you of? The early digital cameras. The early digital cameras had few pixels by few pixels. Now we talk about megapixels. And soon these people will be able to see a very high resolution. Maybe better resolution than I can see with my normal eye. Hey, this camera that sends the signal to the chip, maybe they can send also images with infrared at night. I can't see at night, but these people will be able to see at night. Maybe they will be able to see at 200 meters, and I can't read a newspaper at 200 meters, they will be able to. So even people who are not blind, who can see, may choose to change their eyes with something artificial. And very quickly you'll see people that are cyborgs. You have cyborgs everywhere. Okay? So it's not a cyborg because they lost a limb or lost something, it's by choice, they choose. This is how it looks, this is the chip that is on the retina. And there are different companies now building this. This is another company, I think this one is from Bionic Vision from Australia. And rather than having it as a square, it's a different shapes, but this is the person that is in front of the camera, this is what they see. So here's another thing that will show you why I'm convinced this is happening, and it will happen very quickly as the technology, not just AI, technology in general is moving forward. Yeah, this is another video I wanted to show you, but here I'll show you the demo here. This is a picture. What do you see in that picture? Can you describe this picture? This was taken by police in Vancouver, 2011. So many years ago already, 7 years ago. It was the Stanley Cup final, and of course the Canucks were playing, and everybody wanted to go to the stadium, but they knew that not everybody can get in. So CBC had these big screens in many places in the street, and people can watch the game from outside. They knew something will happen. If they lose, people will smash everything. If they win, people will smash things anyways because they're happy. Like what happens with soccer in Europe. So police had these cameras installed. And what do you see here? People, a huge crowd, huge crowd. And people think, hey, they can hide in the crowd. Do you see the person here? Who can see that person? Ah, you don't have the bionic eye, that's why. This camera is a special camera. It has 2100 megapixels. It's not a camera you can buy like this one everywhere. It's very specialized cameras. And that eye can become that kind of resolution. Look what you can do with this camera. If you zoom in here, well, you don't see that person, this one. Then I can zoom in like that. Boom. That's the picture that you see here. Now you can stop seeing faces, but you still don't recognize that person there. Okay, you see that person there? Not really. You can zoom in further. That person there. So you can't hide in the crowd anymore. And if you have a camera that you can put in an eye that can do that, will you change your eye with this? Very likely. Very likely. Today, with if I use the high definition, high resolution kind of cameras that we have that you can buy in any store, that zoom will be like this. You can't see much. But if we have technology that can be put on that chip in the eye and can allow me to go from here to here, oh my gosh, I'll be able to read the sign 2 kilometers away. So yes, the future is already here. It's just not evenly distributed. So here's what people do. They hack their bodies with technology. Do you know what these are? It's small like a grain of rice, and it's an RFID, and you can put it underneath the skin. And actually now it's installed in many, many places. It's very easy to inject inside in the place where the ears here or the hand, or it's not rejected by the body. And you can use them to identify yourself. And in Sweden, for example, many people are using them to access the train or the bus, or so rather than having a card, they just swipe their hand and they can pay for their bus like that. Some companies have it for their employees. They can buy things, open doors, start the computer, because they identify with this RFID. So it's becoming very, very common today. But people do more than that. These guys here installed LED lights underneath the skin and a Wi-Fi detector. So when they come close to a hotspot, Wi-Fi hotspot, it turns on, and they have this light turning on. Yeah, it's crazy, but people do that. And they do all sorts of things. Here's a guy who installed underneath his skin a hard drive to store data from his wearables. So he has cameras, he has all the things, and he doesn't want to carry all that stuff all the time and forget it. And there you go, it's underneath his skin. They do it on their own, themselves, at home, in the garage. This is called a biostamp. It's a wearable sensor. You print it, and you can erase it afterwards. So the technology is moving very fast and very quickly. Well, it can be legislated at one point. Now there's no rule, no nothing. But this is how we will make technology as part of us. Okay. Any questions so far? I've been talking, and you're like zoned. Oh my gosh, what's happening? Yes?
So the whole like hard drive in his arm, so I don't really get it, like how does it, like is it storing data from like things he uses or like from himself?
Anything he wants. for himself when things he uses, or if he has a camera that is filming all the time what he's seeing, then it's stored there. Then later he says, okay, where did I leave my keys? Well, the camera captured where he left the keys or something like that. He can store anything he wants.
So he has to then like hook it up to a computer and stuff.
Yeah,
so
yeah, yeah.
It's not just like, okay.
It's hard. Yeah.
So does he have to take it out to do that?
No. He doesn't want to take it out, in and out, it stays in there. But I found it silly because that hard drive will become obsolete very soon. And something better will come. But, well, he'll open it and you can see how it's stitched. It's very rudimentary. But this is just to show you that people are trying different things on themselves. It's called body hacking. And some are better than others. In the video that I mentioned, there's this guy from BC. He has actually horns because he put implants underneath, and he's a body piercing guy. And so putting these sensors is not just to try this technology, but it's also part of the culture of body piercing. Art. Well, this is kind of, I don't know how useful that is, but, well, it's art too. People are talking about also having LED tattoos rather than having real tattoos. It's LED and it lights up when you have this or that. Or the imagination is the sky's the limit, basically. Imagine whatever you want to do. Okay, so this is one thing. I wanted to talk about intelligence, and when computers are considered intelligent, and people have been thinking about that for a long, long time. And in the 50s already, this is the 1950 exactly, Turing wrote his book, Computing Machinery and Intelligence. Actually, Computing Machinery and Intelligence, that's a paper. He wrote a book about thinking machines, and in this paper he was talking about a test to assess whether a computer is intelligent or not, or at least as intelligent as humans. And the test goes like this. You have two rooms, and in a room you have a human assessor. In the other room, you have either a human or a computer, you don't know. The assessor doesn't know. And through these, the wall between these two rooms is there's a connection, and you can communicate with that entity, human or machine, on the other room. If the human assessor in the first room cannot determine whether it's a machine or a human, then that machine is actually intelligent, because it managed to fool the human that it is a human. Does it make sense? That's what we call it a Turing test. Okay. And the Turing test, for many, many years, people have been using it to assess AI. To the point that it became a huge challenge in a game for many. They were building these chatbots to try to fool humans that they are humans. There are many chatter robots that exist online. You can find them online. People have been building this. And then there was a Loebner Prize, a rich guy who said, okay, the one who beats the Turing test first, I will give them $100,000. So that added fuel to the fire, and more people were trying to build these chatbots. And every year they had this competition. And then for many years they had well, best, second best, and third best, but nobody was able to fool the human. You have to fool the human, a set of humans, not just one human, for at least 5 minutes. So in the first 5 minutes, a third of the human assessors cannot determine, and it fooled them. So here's one case. Got the third prize in the Loebner, third place in the Loebner Prize in 2003. In 2008 they were fourth. You can go and test it, johnwacky.com. And I did a test. So obviously the animation is not in order. So I'm asking it, it asks me, what is your name? And I said, I'm Fred. It says, no, it's not. What do you mean, I'm lying? It says, yes, I'm very good liar. But it isn't a good liar, and it's accusing me of being a liar. So that doesn't mean I'm the liar, if you are a liar, if you're a good one. And then it says, yes, it does. Why is that? Why does it mean that I'm also a liar? And then it says, I am God. Oops, wow, that's amazing. And then I say, do you have a temple for you? And it says, nope, that's all right. So you're God with a small g, because it draws with a small g. And then it says, I'm small g. So it's almost random kind of discussion. You can very quickly realize either somebody who's completely drunk, or it's not a human. Here's another case, Alice. Alice won the Nobel Prize in 2001, 2002, 2004, was 5th in 2008. And Alice, hey, I'm Alice, and anyways, I'm going through quickly. Where are you? It says I'm in California, and it says, and it asks me, oh, where are you? Oh, school, that's nice. It says me too. So I say, I'm in Canada. And tell me a little about your life in Canada. Okay. That's interesting, but you can see this is a canned kind of question. Life in whatever place I'm from. And I said, well, about Canada, it's cold. And it says, I'm warm here. Wow, it's comparing that California's warm and I'm cold. Where is the best Chinese restaurant? I think it's a Thai. Thai, because I asked best. Who's best at this? Like chess or whatever. It says a Thai. So it didn't understand Chinese restaurant. Why is it a Thai? Why do I exist? To test artificial intelligence? What is the same? I mean, it's completely out of whack. Makes no sense. So it's not a human. Cleverbot, another machine. Finalist in the Government 2008. Oops. Same kind of thing. And at the end you realize, oh my gosh, it's completely dumb. But then a few years ago, this was in 2000. About 2 or 3 years ago, there are guys who had this idea. They said, since it's the question of fooling the judges, the best way to fool them is to make them more indulgent on mistakes I can make. So they pretended to be Eugene. Eugene is a small boy from Ukraine. So he's not fluent in English, and 13-year-old, so it's a boy, it's not an adult, doesn't know everything. And indeed, they fooled 39% of the judges in 5 minutes. And so they're the first, this is when I'm testing it, I don't know if I go fast, you can read it on my slides after. This was 2014 paper. And this is the first one that beat the Turing test, and now we say that the Turing test is not a good test for smart machines. But these chatbots are becoming very popular today. You're not chatting with them like this is really silly, but you have these virtual assistants like Siri, like Google Now, Google Home, you have Cortana from Microsoft, Amazon has one, everybody has these ones, and they're slightly different. They're more for information retrieval. You say, okay, what is the capital of Iran? And it'll tell you it's Tehran. How many people live in New York City? It will tell you these facts. Okay. Or you can give it comparative. You can give it orders. Call my daughter, or call home, or start an email. You can give it orders like this, and it knows how to do it. Or add this in my calendar, or something. You can't have a fluent kind of conversation with these agents yet. I want to finish faster here. We talked about these driverless cars. Yeah, so AI is important, will be important in your lives, will be important in your jobs. I don't know if you're all in medicine. I showed you the examples in medicine. It's changing medicine very quickly today. So it's not just important to improve a number of applications in many, many, many fields, but it's also important to understand and appreciate the human beings too. How this brain functions. Okay. By studying AI, we're actually trying to study ourselves too. Another thing that another message that I want you to keep from these lectures is that AI, at least for me, is like a tool. It's like a hammer. I, as a human being, build a hammer so that I can push that nail. And AI is also a tool that we will use to extend our own capabilities, like this hammer. Because I can't use my hand. In the beginning, I tried to grab a stone and hit the nail, and then I build a hammer, which is better. Okay. Oops. So it will also enhance my creativity in many, many, many domains and fields. Okay? It's not the machines against us, the humans. I don't want you to keep that in mind. Just think about how we can build the best tool to do our job better, and not to replace us. So that's the end of the third part. Any questions? Yes?
How do you think it'll help us enhance creativity? Like, I understand it could be a tool for, like, I guess, monotonous tasks like data entry and things like that, but how do you think it'll help with creativity?
Well, it's a tool. It helps me, for example, the hammer helps me now build a better house, a bigger house, and I wasn't able to even conceivably think about a house like that before. I didn't even imagine it, because I know that I can't do it with just one stone and nails. Now that I have a tool that can do things better than I can do them, I can use that tool to create other things that I didn't imagine before.
So do you think AI will ever be able to have idea generation, or do you think it'll just aid humans in their idea generation?
Interesting question. Can AI come up with new ideas, new suggestions? I think it can. Many people are working on using AI for creativity, in the arts, for example. They're not like humans yet, but they're improving. So we can draw things, so we ask the AI to imagine things and draw them. We can also imagine poetry, create poetry with AI. All sorts of creativity, we are exploring now AI to see if we can do that better too.
So if you look at what the game of Go looks like, once computers surpassed human players, you know, the beauty of what was going on the board increased amazingly, and there were, you know, configurations that no human would have never.
They had strategies of the game
Yeah.
that no human thought about before. They said, wow, this is amazing.
Yeah.
And that's the same thing with poker. Because the poker game that we designed here at U of A, it played more poker hands than humankind in the history of the poker game. So it has way more experience than us together. So it becomes creative in how to play.
So in a sense, there isn't any question that they will be more creative than we are. It may not be the kind of creativity that you value in yourself. It may be in something you can't do at all. But there is creativity also in things that humans cannot do. And certainly, you know, machines are being creative today in that sense. In 2001, I was at a conference with a screensaver that had an artificial intelligence painting program. And the person in charge of the conference was one of the best speakers that I've ever seen. But she herself was transfixed by this.
Some of the results.
And she said, I don't think I can compete with that. So that was in 2001. So, you know, there's just no question that this will happen. But
Even designing cars, how the car looks and things like, yes, the humans are playing a huge role in the design, but they're using computers to help them design cars. Now even in clothes and whatever, anything that you use and you take for granted, they're using the tool, the computer, to help the designers design and create.
if you look at your phone, the record of calls that you've made, there are fewer and fewer calls to human beings, more calls to automated, you know, attendants. And probably your friends would consider it very lame if you actually picked up the phone and used it for an audio phone call. You know? And that will be more and more the case. In 2018, the percentage of calls that are to another human is at a certain point, and every subsequent year it'll go down, down, and down. And then if you look at the calls to automated attendants and how successful they are in, you know, completing whatever you were trying to do, 10, 15 years ago it was terrible. It was frustrating, you know, everybody complained. Now it's faster than if you had reached a real human, and we'll just get better.
Other questions?
I have a question.
Yes?
So you know how you were talking about animal intelligence and then how emotional intelligence and things like that. So does that mean you consider emotional intelligence necessary for intelligence itself?
This is a philosophical question. Is emotional intelligence necessary for intelligence? I don't think so, but it gives us something special, we humans, and animals. Animals are also emotional, they have emotions. And I know that computers don't have emotion. They don't care, they just do what we ask them to do. We can emulate emotion. We can detect emotion, so the computer can detect emotion from faces, from writing, from speech. We can tell a computer what to do when they detect this emotion or that emotion. I have a student who's actually working on expressing emotions in text, but the computer itself doesn't have that emotion. No, we do. We can be sad, we can be happy, and that emotion dictates our decisions.
Yeah.
The computer is very consistent. But is that important for intelligence? That's the question. I don't think so. No. We can be intelligent without being emotional.
And there can be alien intelligence. I mean, if you think of octopus and squid and so on, there are a number of things that they do that are completely unlike anything that we do. And, you know, there's a kind of independent brain in each tentacle. They can match the color of their, you know, surroundings.
We don't know if they're emotional or not.
No. But I mean, you can imagine an alien intelligence that did not have emotions at all, but had some other facet that we completely lack and cannot really understand.
Emotions can be a handicap, not necessarily a positive thing.
I think the emotions could trigger you to do something.
Yes,
To
definitely.
have your own ideas.
Definitely.
But if the AI could not have their emotion, that maybe they were only to follow the person's instruction. They could not to have their ideas to what I want to do, or I want to change something to, yeah.
The emotion can be the reward that we are trying to get. I'm doing this because I'm going to get happier.
I think what you just said isn't quite correct, that without emotions, it will just do what it's told.
Yeah.
Computers are already capable of generating random numbers, of randomness. I mean, if you look at both of the, robotic animals that I brought, their behavior is not completely predictable. And so it isn't that if they don't have emotions, they'll just do what they're programmed to do. There can still be a lot of...
Machine learning is making computers do things without explicitly telling them what to do.
Yeah.
Only telling them how to learn. But what to do and what to do with what they learn is something that they do on their own. They tell me. If I say, okay, here's a set of pictures that have cancer, here's a set of pictures that don't have cancer, and then give another set of pictures, say, okay, now tell me whether they have cancer or not. I didn't tell it how to identify where cancer is. I didn't tell it at all. It decided by itself by analyzing the two sets that I gave before.
So even the AI was developed very well, actually it can act as a role of assistant, but not a...
So it's basically, I'm saying that it doesn't do only things that we tell it exactly what to do.
Yeah.
Computers are already able to do things that we didn't tell them how to do. And they don't have emotions.
That's why I'm a bit skeptical, not skeptical, but I think it's strange that whenever we talk about artificial intelligence, we just assume that it'll turn into a human-like intelligence or become self-aware. Because just because it's extremely intelligent doesn't mean, it doesn't necessitate that it has a concept of self, right?
No, I agree. And our intelligence is not the only form of intelligence. There are many other forms of intelligence. You just mentioned the octopus. An octopus is intelligent. You can put it in a bottle and it can, from the inside, know how to open that bottle. I saw the videos. It's amazing. They are intelligent, but they're not. Our intelligence is completely different.
And their intelligence has gotten a lot more interesting. We thought they were like solitary and we couldn't imagine how they could enjoy their lives. Turns out there are these octopus villages, but they're really tough, They're like the old West where people are really mean to each other and so on. But the animals live, together with like rule-based interaction and all that kind of thing. So really, they are quite intriguing beings with lives.
The thing is, we are as humans, we are the most intelligent beings that exist on the planet, and for a long time that's all we knew. So we consider everybody else not intelligent, and we are the only intelligence.
Yeah.
And we are now arrogant, thinking that intelligence is only like us and it can be different. But there are many forms of intelligence, and some can become superior to ours.
Yeah.
Yeah, I mean, one of the things will happen, that's the subject of a lot of science fiction, is increasing the intellect in other animals. We will be able to do that eventually as a part of things we learn about how to, increase our own intellect. With a dog or cat or other pet that you can raise it up to a point where it can actually talk to you and so on. So that's, another part of the future.
Thank you.
Yes.
Thank you.